Okay, today we are going to analyze the process of factoring quadratic expressions. Just as a reminder, let's remember that to factor a quadratic expression means that we're going to write it as the product of two linear expressions. In other words, we're going to go back in the FOIL process, and instead of having a polynomial like this one, x squared plus bx plus c, what we need to find out is the two linear expressions that created this problem, okay? In order to do this, the process of factoring requires that we find the following combinations. For example, to find the value of b, we need to determine the addition or subtraction of p and q, okay? The elements p and q that are in the parentheses. And to determine the value of c, we need to find out who is the multiplication p or q, p with q. Now, this process works only for quadratic expressions that are considered factorable. That means in some cases, there are polynomials that cannot be factored, okay? So let's find out the first examples that we have. The process of factoring a quadratic expression of the form x squared plus bx plus c can be organized in 4 cases. And this depends on the signs that b and letter c has, okay? Now, let's analyze case number 1. Case number 1 says that, we're going to factor when b or c are both positive numbers. What do we mean by that? Okay, we're going to establish a procedure right now, okay? And the procedure goes the following way. First of all, I need to break up the factors of x squared. That means x times x. And then I need to look for the factors of 2, okay? In this case, it will be only one pair of factors, which is 2 times 1. So, to apply the factoring process, what we're going to do is we will open up 2 parentheses. And on the first parenthesis, I'm going to write letter x. On the second parenthesis, I will write the second x. The first sign that I have in here, which is positive, goes in the first parenthesis. And the second sign that goes in the second parenthesis is the product of the 2 signs that I have in here. Positive and positive will be a positive answer. Then I look for 2 numbers whose multiplication is 2, and because of these 2 signs that are equal, then the addition will be equal to 3. And that combination is unique because it's 2 times 1, which is positive 2, and 2 plus 1, which is equal to 3. So therefore, we write 2 on the first parenthesis and 1 on the second parenthesis. And with this, we finish the process of factoring the polynomial. Now, we can check if what we did is correct, okay, by applying FOIL method, okay? So we apply the FOIL method to the process, okay? And we start multiplying. For example, x times x will become x squared. X times 1 will become 1x. 2 times x will become 2x. And 2 times 1 will become positive 2. So if you simplify this expression, because in here I have like terms, the final answer will be x squared plus 3x plus 2, which is exactly the same original problem. That means the factoring was done correctly, okay? Let's analyze the second case. Let's factor x squared plus 8x plus 15. Again, we break up the factors of x squared, which are x and x. We look for all the possible factors of 15. So in here, we're going to have 15 times 1. We're going to have 5 times 3. Okay? I write all the possible factors in here, but then I'm going to choose only the one that I really need. So let's look to the process. We open up the parentheses. We copy X on each parentheses. We bring down the first sign. Remember, the first sign comes in the first parentheses. And then the product of the two signs, positive and positive, goes on the second parentheses. Okay? As we have this, then we are ready to start looking for the combination. The two signs are equal in the parentheses. Then I look for two numbers whose multiplication is 15 and whose addition will be 8. And in this case, this is the only combination that works. So we write 5 in the first parenthesis. We write 3 on the second parenthesis. And there we have the problem completely solved. Okay? So the checking is left for you, okay, so that you can apply the FOIL method and verify that the original polynomial is the right answer. Okay? Now, let's move on to some other examples so that we can fix the idea of the process. Here we have x squared. Okay, example number 3, we have x squared. And we have 56 in here. So we break up x and x. We break up 56 into all its factors. And here we have a lot of them because I have 56 times 1. I have 28 times 2. I also have 14 times 4. And I have 8 times 7. Okay? So one of these combinations is the one that is going to work in this problem. So we open up the parentheses, we create the x and the x. Okay. Then we bring down, remember, the first sign comes in here, and the multiplication of the two signs comes in here. Okay, so positive and positive becomes positive. Now I look for the combination that gives me two numbers whose multiplication is 56 and whose addition will be 15. If you analyze all the combinations in here, they multiply, give you 56. But only one of them will give you 15, and the right one is this one. So we copy 8 and we copy 7 in here, and here we have the factoring of this polynomial. Okay? Now let's analyze problem number 4. We still have the same situation, x times x. Then I have all the possible combinations for 20. 20 times 1, 10 times 2, 5, and 4. So we start analyzing. Okay, and we start the process. We open up the parentheses. We copy x on each one of them. Remember, the first sign, we bring it up. The multiplication of the two signs goes in the second parenthesis. And then we look for a combination whose multiplication is 20. All of them give you 20. And whose addition will be equal to 9. So if you check, 20 plus 1 is 21. 10 plus 2 is 12, and 5 plus 4 is 9. So this is the one that really works. So we copy 5, we copy 4, and here we have the process that we needed. Okay? Now, we're going to analyze case number 2. In case number 2, as you can see, the particular thing is that B is a negative value, and C is a positive value. Okay, but the process is always the same. Okay, we're going to break up the x squared into x and x. We're going to look for all the combinations for 6. 6 times 1, 3 times 2. And then we will start the process. Okay, we open up the parentheses. We apply x and x on each parenthesis. We bring down the first symbol in here, the minus, and then I multiply the signs. Negative and positive becomes negative. Now, take a look at this. These two signs are exactly the same. So I still use the same principle as in case number 1, sorry. I am going to multiply to get 6, and I'm going to add to get 5. So 6 plus 1 is equal to 7. 3 plus 2 is equal to 5. This is the right combination. So we copy 3, we copy 2, and then this is the final answer. In example number 6, we have another situation very similar to the first one. So we break up x squared into x and x. Then we break up 8 into all its possible combinations, 8 and 1, 4 and 2. And then we start opening up the parentheses, okay? So we open up here x and x, then we take negative as the first sign, and the multiplication of these two signs, negative and positive, will become negative, comes in here. Again, the two signs in the parentheses are the same, so I look for the combination whose multiplication is 8 and whose addition is 6. Now, 8 plus 1 is equal to 9, 4 plus 2 is equal to 6, then this is the one that I really need for this one. So I copy x minus 4 and x minus 2, and that is the answer that we need, okay, as the factoring of x squared minus 6x plus 8. Remember, you can verify all your answers, okay? You can verify all your answers by verify all answers by applying the FOIL method. Okay, once you apply the FOIL method, you will check that the original polynomial is the answer to the multiplication. Okay? We continue with some other examples. And let's analyze exercise number 7. Exercise number 7, we have x squared minus 15x plus 36. So here we have the breaking up of x squared, which is x and x. Now I need to break up 36 into 36 times 1. I'm also going to have 18 times 2. Then I'm going to have 12 times 3. I also have 9 times 4. And I have 6 times 6. So if you see, I have a lot of combinations. Okay? Now, only one of them is the one that is going to work. So let's see which is the correct one. Okay, we copy x and x. We copy the first sign that is negative. Then we multiply the two signs in the polynomial, negative and positive becomes negative. And since we have equal signs in the parentheses, I look for the addition, right? The addition, remember that. That is going to give you 15. Now, 36 plus 1 is 37. 18 and 2 is 20. 12 and 3 is 15, so we have 1. 9 and 4 is 13, and 6 and 6 is 12. So only this one will work. So you copy 12 on the first parenthesis, and you copy 3 on the second one. If you analyze, I am always putting the bigger value. Okay, the biggest of the two values, I am always putting it in the first parenthesis. Always do apply that as a pattern, okay? Now let's solve this one. Factor x squared minus 9x plus 14. I have x squared, so I need to break it up in x and x. I have 14, so I need to break up all the possible combinations. 14 times 1. And the other one, which is 7 times 2, right? So we start the process. We open up the parentheses. We have x and x in here. The first sign, is the negative one, so I copy it in here. The product of the two signs, negative and positive, is negative. And since these two signs are exactly the same, we look for the addition that is going to give me 9. Okay? The multiplications are always 14, so I look for the addition that gives me 9. 14 plus 1 will be 15. 7 plus 2 will be 9. So this one is the one that I really need. So 7 and 2. Okay, so here we have the problem solved. Okay? I hope that this video will help you. Please, as a guided practice, do exercises 1 to 4 here at the bottom of the page and have them ready to be discussed tomorrow in class. Have a nice day. Goodbye.